This is the Boring Climate Podcast, a platform where we encourage serious climate conversations. Today's theme: the enigmatic Indian monsoon. If you're an Indian monsoon researcher or enthusiast, you would be familiar with the Rajeevan dataset. If you aren't, but work in the field of agriculture, policy, water, or even finance, say derivatives or climate investments, then you can't ignore the Indian monsoon. And if the monsoon matters to you, then you can't ignore the Rajeevan dataset. That's because Rajeevan dataset helps us understand the Indian monsoon better. And today, we have with us none other than Dr. Rajeevan, the person behind this dataset. Dr. Madhavan Nair Rajeevan is a distinguished climate scientist whose career spans nearly 4 decades. He began his journey with a master's and PhD in physics, leading to roles in the Tata Institute of Fundamental Research, the India Meteorological Department, and the Indian Institute of Tropical Meteorology. He went on to serve as secretary to the Government of India in the Ministry of Earth Sciences, where he spearheaded initiatives like the Deep Ocean Mission and India's blue economy and Arctic policies. His research has helped advance our prediction models and create high spatial resolution datasets. Join us as we try to learn more about his work and gain tangible insights from from this information. Welcome to the show, sir.
Yep.
So we'll start off with the basics. The Indian monsoon is an enigma, and it has been romanticized by scientific and artistic minds for generations. And I think the reason that this has happened is because it's so complex and hard to understand. So, why is the Indian monsoon so complex? How does it develop? And what are the factors that influence the outcomes?
Yeah, that's a good question. So we as Indians, we have two monsoons. One is southwest monsoon, which is basically during June to September, and another is a northeast monsoon during October to December. That is more confined to southern peninsula. And monsoon is bread and butter for a country like India because it provides 70 to 90% of rainfall for the whole country. And also it helps agri farmers, it helps water resource management, it helps energy. So monsoon is very dear to us, and it also affects our Indian GDP. Once the former finance minister told that monsoon decides the Indian budget, not me. So monsoon is very important to all of us, and monsoon is very complex in the sense that we understood the basic science of monsoon, but then still we don't have answers to many questions of in monsoon. So last 100 years of research showed that monsoon is a regular phenomena which occurs during, for example, June to September. It starts from in the southern hemisphere. It's called Mascarene Player High near to Madagascar. It starts from the flow starts from there and crosses the equator, and it becomes a southwesterly winds. And so that's why we call southwest monsoon also. Then it gives a copious amounts of rainfall during June to September. The basic concept of monsoon is basically the temperature difference between land and ocean. During summer, the land gets heated up very quickly, and ocean is a little relatively cooler. So the land will be hotter, so pressure will be lower there, and ocean will be cooler, so pressure will be higher there. So there will be a pressure gradient from southern hemisphere to northern hemisphere. That's basically a driving force of the monsoon. That's a very simple way that you can describe how the monsoon is. But if you really go in detail, there's a lot of complexities, how it varies, how it comes, how it goes, how it varies from day to day time scale, as also the seasonal time scale, year to year variation. So much more complex. And but thankfully, because our research and data sets which we have generated, including satellite data, etc., and we have state of our climate models, and so we can really test our hypothesis in a model and try to find out what exactly monsoon is. So our understanding of monsoon has improved substantially. What we knew 50 years back is not the same what we know now. We know much better now. But still, there are a lot of uncertainties, questions, etc. still remain. So it's monsoon will always remain a kind of a complex system which we never understand fully.
You mentioned that we'll never understand it fully, but in your view, what is the most misunderstood aspect of monsoon variability and forecasting?
So in monsoon varies in different time scale. For example, in a particular place, you have annual variation. I mean, it doesn't rain all 24 hours when it rains. It rains in a particular time systematically. So, for example, if you go in northern parts of the country, the rain is mostly in the afternoon. And if you go close to the Himalayas, the foothills of Himalayas, it is in the early morning. So then when the west coast, it is a different time. So this is called, we call diurnal variation. Then we go into a 4 to 5 days time scale. The monsoon varies again because of the synoptic system. We call weather systems moving here. It gives rain. Then on a 10 to 30-day time scale, another variability. We have active and break cycle we have. I mean, some days it will rain more, then followed by a dry spell in which there may not be enough rains. Then again, we'll have a wet spell or active spell we call. So this is called intra-seasonal variability. Then within the season, how the monsoon varies. There's a lot of year-to-year variability of Indian monsoon. For example, 2024 may not be same as 2025. And we know why it occurs and all. So, but then still we have not understood many aspects of year-to-year variability. And we know the Pacific Ocean, or so-called the El Nino events, is really forcing the monsoon variability and year-to-year variability. But there are also now new results coming out. Indian Ocean may be playing a role. Atlantic Ocean may be playing a role. Arctic Ocean, Arctic sea ice, for example, playing a role. So, and all this forcing also may interact each other, and there will be complex feedback processes. Monsoon is, unfortunately, it's not a linear process, it's a non-linear process. Any small things happen, it can have a feedback into the system, and whatever we think may not really happen. It may go to the next stage. So that's why it's very highly complex. So, but still, we as scientists, we still try to explore how the monsoon is, why it varies from year to year variability, or biennial variability, or the interseasonal variability. Try to understand. Then the most important aspect is try to predict it. Because prediction is more important. So just understanding that it doesn't give any value, societal value. So we need to really predict. So we have models to predict these variabilities. And probably I will discuss these issues little later in the.
So you mentioned the El Nino, La Nina, the so-called ENSO events that affect the monsoon. How far away are these impacts coming from? So there's ENSO, and then are there impacts from the polar regions? Are there?
Yeah, so as I told that Indian monsoon, I'm talking about year-to-year variability is influenced by El Nino and La Nina. So that's called so-called ENSO phenomena in the occurring over equatorial Pacific, and also Indian Ocean playing an important role. So-called Indian Ocean dipole events. Positive Indian Ocean dipole event will contribute to more rain. Negative IOD events will contribute less rainfall. Like El Nino contribute to negative rainfall, and also the North Pacific plays an important role. Another is Atlantic Ocean. Recent studies say Atlantic Ocean also can play an important role in year-to-year variability monsoon. Now, recent studies that even Arctic Ocean plays an important role. We all know because of global warming, Arctic sea ice is melting very fast sea ice. And the melting of sea ice can have an impact, a devastating impact on Indian monsoon through Atlantic Ocean circulation, etc. So, you may ask how the Indian monsoon is affected by the process which are occurring thousands of kilometers away. So all it's called atmospheric teleconnection. So any change in the ocean temperatures can have an impact on the overlying atmosphere, and that can propagate to Indian monsoon region. So it's called we call teleconnections. And in the equatorial region, we have so-called Walker circulation, and Walker was one of the Director General of IMD. He is the person who really started monsoon forecast, seasonal forecast, Sir Gilbert Walker. And he's a very famous person. So he did a lot of work on. So he only found out there is a kind of a Walker circulation prevails over the Pacific. Just to imagine, he worked in 1920s where observations are not that good. There was a lot of no aircraft, no satellites, but still with small observation which we are. Only thing is, he was from the UK government, so British government. So British government was running the whole world. Isn't it? So they had presence everywhere. So he could get all the data, and from a small data set, he could say that there's a kind of Walker circulation, ascending motion over the Indonesian region, and descending motion over the East Pacific Ocean. During El Nino, it just get reversed. So ascending motion will be there, and descending motion over Indonesia will affect the Indian monsoon. So that's why when El Nino is, we tend to get less rainfall. So Walker was very great person. Now, I am very happy to say I was given 1 year back a Sir Gilbert Walker Gold Medal for the lifetime achievement by the Indian Meteorological Society. And I was very happy to work on in the seat where Sir Gilbert Walker was working on monsoon forecast. I occupied the same seat And I contributed monsoon seasonal forecast models, etc. And after many years, they give me an award saying that's a Gilbert Hawker Goldberg for you. Thank you for the Meteorology Society.
So we can say that we have some amount of accuracy in the prediction, but there is a lot more that we can understand. So that's maybe something we'll explore a bit more. But before that, if we could just step back to the history of monsoon studies in India. So this is, I think, the 150th year of the IMD. How would you say IMD's monsoon monitoring capabilities have evolved in this time, and like key technological advancements that have happened?
Yeah, in fact, that's by before 18 monsoon, sorry, IMD was formed in 1875, the first scientific department for weather forecast in the country. And before 1875 itself, there are 60 observatories were there. British people have kept that observatories, built that observatories. And so from there, the observatories started growing, number of observatories, especially number of rain gauges. And British people are so good that they kept rain gauges everywhere, wherever they find place, they kept it. So now, frankly speaking, we have about 8,000 rain gauges in the country. It's really good. One of the very rare countries in which we have maximum number of rain gauges. The density is very high. And as far as observatory is also concerned, then we are at that time, it's all manual observation. Somebody has to go and take measurements of temperature, pressure, etc. It's all manual observatories. We have now about 550 observatories, manual observatories. And the so-called automatic weather stations have come a few years back. So we started installing automatic weather stations. So the observation, then we have kept the radars, Doppler radars especially. And also we have radio sound with send balloons up, and then we take measurements of the temperature, humidity, etc. in the vertical plane. And so these all observations have increased a lot. But if you ask me a question, are you really happy with the present network? I will say no. So there's a lot of scope for further improvement in the network. And first of all, the quantity should improve. There's a lot of observations are required. At present, we have, for example, observatory 550 means what? One per one district, which is not really good enough. So we need at least per one taluka or panchayat level. So we need to increase the network density. And also, we have only some 38 Doppler weather radars. We need to go up to only 70, 55 to 60 weather radars. And also we need profiles, so we call wind profilers. So a lot of new technologies come, but IMD has not really started implementing it. Now they are doing it, but it's my personal feeling is still late, so they should do it quickly. So-called the wind profilers, etc. It's a relatively new technology, and it's all very useful data sets will come out. So there's a lot of scope for improvement in the IMD's observational network.
You earlier mentioned about knowing the monsoon is one thing, but predicting it is another thing. So when you talk about monitoring and modeling, we can't escape the Rajeevan data set, right? So how can you explain the Rajeevan data set to us, and what did you consider to ensure it is accurate, its output is accurate?
See, but Rajeevan dataset is well known because there was a time when I was in IMD Pune as the director of the National Climate Center. So there is a lot of criticism even then, even now also. The IMD doesn't provide data. That's what the complaint is. IMD dataset is not available for researchers. So if you really want to do research on monsoon, and especially people in universities, etc., they need data. And so rain gauge, especially rain gauge for some rain gauge data. So there was a lot of scope and there was a lot of requests, there were complaints. And I was told by my seniors that we can't you develop a data sets and give it to the people. So that's that's the beginning of the Rajeevan data set. But it took a lot of time for us. It took almost 2 years to develop that gridded data sets. And we gave almost free to the people. And we, especially for research, we did not charge, and only the commercial people we charge. Now the data, once I became the secretary, I made it open. So it's all data available in the website, anybody can download it. And the data set, see, unless you have the data, you cannot do research, isn't it? So this data set has really provided an opportunity for the researchers, not only in India, the whole world, to understand the variability of monsoon, basic dynamics of the monsoon. I'm very happy to say that with that data, now there's 1,050 research papers have been published. It's a really remarkable achievement. If the data set was not there, this 1,050 research papers would not have come. So I'm very happy that I could bring out the data sets, and I should really thank my bosses, for example, Director General Meteorology, etc., who really encouraged me to publish that data set. So this was in 2006. So So my point is that if you really want to do good research, this data information, especially the basic data, should be freely available. I'm talking about meteorology. Any science, if you take, the data should be available. Information should be available. Otherwise, how they can do it? To generate this data, it involves a lot of time. So you cannot simply generate it. So once data is available, you put it in a particular format which are convenient for the researchers to do research. So that's what I did. So I'm happy that it is yielding a lot of good results. So
And how does it work, sir? How, if you were to
it's a
explain?
gridded data. So you take all the engages and interpolate into regular grids of about. We started with 100 kilometer. Now we have my successor, Dr. Payas, developed a 25 kilometers, in which I was also part of the team. So we have a 25 kilometer resolution data set. So we interpolate into a regular grid and then do a lot of quality control. So the actual rain gauge data is all archived data. So it's available in National Data Center in Pune. But then there could be a lot of errors. It's manual observations. Somebody may put it in inches, then somebody may not convert into millimeters. So assume that 2.54 is inches. So 1 inch is 2.54 millimeter. So then this kind of issues are ought to be sorted out before we interpolate it into data sets. And so that we have done a lot. And there will be a lot of discontinuity. Some days data available, other days some data are not available. So we need to really do this kind of interpolation very carefully. But we have not done very subjectively. We have done everything in a very objective way in using mathematical equations, etc. So we have done it very well. So if you really see how accurate it is accurate. That's all. We can say that we have cross-checked with other data sets, for example. And also we have seen some systems forming, how much rain it happened. So compare with the local rain gauge data, station rain gauge data, and see how the data sets, our data sets are. Once I published data, we published the data sets. So I should not say I published it. So I should always say it's a teamwork. So it was a team. So we published the data in 2006. Then subsequently, there were a lot of data sets come up from IMD as well as the global data sets. So our IMD data sets are still very comparable and very well appreciated, well respected data sets, which still people keep using it.
And are there situations where the data set does not work in comparison to global counterparts?
No. Our data set is really good.
Okay.
So really good. And the only thing is the resolution is the original data set is a resolution 100 kilometer. And that then we made it to now 25 kilometer. So the 25 kilometer means you have better information. So that now 25 kilometer also data also is very extensively used by researchers. So, but this quality of the data is good. So this is what we are emphasizing, that quality is good.
Right. So how are observations useful and important for understanding the monsoon physical processes?
My observations are very important. As we know that in a day-to-day basis, IMD takes a lot of observations, meteorological observations. And these are, of course, those data are very useful for understanding monsoon. But then we need very specific observations. For example, monsoon clouds. Monsoon clouds are very tricky. It's a very cloudy issue. And so understanding the cloud physics, the physics of the clouds in forming during monsoon season is a very challenging problem. So, because clouds are in the sky, so we cannot simply every day go and take observations. So, we need a lot of observations on clouds to understand whether the clouds are well represented in the models. Ultimately, clouds only will give precipitation. So, if clouds are not well predicted in the model, the precipitation also will. Precipitation or rainfall is the end product of the model. So, all the errors which are getting accumulated in the model will ultimately reflect in the rainfall forecast. That's why rainfall forecasts are not that good. You can predict wind, temperature, everything. When rainfall comes, because it's the ultimate product. So the clouds, the prediction of clouds in the models are prediction of clouds in the model is very important. At present, the models are not doing that well. So we need observations. So we have, for example, Ministry of West Science has launched a lot of observational program to understand clouds. Some Indian Institute of Tropical Meteorology in Pune, they launch a lot of observational using aircrafts. They go to the clouds, inside the clouds, and taking observations and bringing back the data, analyzing how the cloud physical processes are happening. And that's one. So we had done a lot of work. And 2018 and 19 under my leadership, and we had launched a big project in Solapur, Maharashtra, where we try to understand how the cloud seeding project, so many people do the cloud seeding, artificial rain, how that is effective in producing rainfall. So 2 years observation, 240 flights we have done with the 2 aircrafts and the radars. It's a huge expense. We spent about 200 crore for that. So, but then we got a lot of good results. And another important thing, we had a lot of observations now on cloud, so which we can use it for improving models. Another important thing is on ground base. So there is a place called in Bhopal. We set up there's a concept in meteorology is called research test bed. That means observations plus models you do at that particular place for a specific work. So anybody who wants to take observation, they can come and so we'll keep the instruments there. So anybody wants to do observation, they can come and collect this observation and do research. And there will be a lab here, there, and it's called research test bed concept. It is there everywhere, but in India it was not there. So when I was secretary, we launched a research test bed in Bhopal. We got 100-acre land from Madhya Pradesh government free of cost. So we have kept a lot of instruments and not all which we really wanted. So that slowly they will improve it. And so what will happen when the monsoon low pressure system forming over Bay of Bengal, it keeps moving over across central plains. So it moves across Bhopal area. So we have kept radars, we have different kinds of radar, we have a lot of rain gauges, we kept a lot of cloud observations. So this all will be useful to collect this data on cloud processing process. It's not research test beds. And we are also setting up a research test bed in Mumbai for some heavy rains. And for thunderstorms, we are setting up in Odisha. So these are all some of the research test bed concept which Indian government is doing. So this ultimately, these all will be very useful for improving understanding of monsoon physical processes.
So you had earlier touched upon monsoon variability and the different factors that affect it. One of the questions is how much of this, why is it important, first of all, to study this variability? What is its impact on agriculture, economy, even disaster management? And the second part of that question is how much of the variability can we attribute to climate change, or how much of it is purely due to natural systems that are in
Yeah, it's
place?
very good question. So, first of all, I'll talk about the year-to-year variability. As I said that 1 year monsoon performance may not be same as next year. So there can be 1 year can be good monsoon with a lot of floods, and another year can be completely a drought. For some, 87 was a drought, but 88 was a really good monsoon. So within 2 years, things can change a lot. And for agriculture, earlier days, agriculture used to contribute almost 50% of India's GDP. 30, 40 years back. But now only it's 15%, just 1.5. So 15, even though the agriculture output is really impacting India's GDP. And so earlier studies have shown that the Indian monsoon is very important for the agriculture. So if a drought happens, when there will be agriculture drought will happen. And it will lead to less agriculture output, and that can impact the another important aspect is the farmers. Number of farmers involved in the agriculture process is very now very high number. Okay, so even though we may be able to save the crops, but if for example a farmer doesn't have enough money during that year, it's all year for some our farmers are small farmers. A particular year, if they don't get good crop, they won't get money, so they'll be on loss. So if you get more money, he can spend more money, isn't it? For example, buying a TV, buying a bicycle, buying a scooter. For some particular year, he doesn't get enough money, so he won't buy anything. Isn't it? He will try to save that money to eat some food. That's all. So then it will apply. It will be an impact on service. It will impact on industries. It's a chain process. Agriculture is really very important for the country. So monsoon is really an impacting in agriculture. So earlier studies on, for example, one study by Sujana Godgil, etc., has shown that a drought, a severe drought, or like for example 2002 drought, can pull down the GDP by 2 to 3%. It's a big number, 2 to 3% of GDP, only because monsoon is not good. So now people say that Indian government is so good, so resilience is very high. Even though we may have a drought, then the impact on GDP could be much less than the earlier years. That may be true, but still a drought is a drought. It can really have a serious impact on not only in GDP, the general life of the people in the country. So then we need to predict it, isn't it? So then the Indian government will wants to know before the budget or even after the budget whether this year will be a good monsoon year or we will have a drought. And so that we try to predict. So seasonal forecast is what we call seasonal forecast. Before the monsoon season starts in June, we give the kind of information to the government saying this year is could be normal monsoon, this could be a drought, this could be a good monsoon, excess monsoon, and for that we develop models. So, frankly speaking, it's a very good news to say that India was the first country to start the seasonal forecast in the whole world. And the first forecast was issued on 4th June 1886. 1886. And at that time itself, the government was, then the British government was realizing that monsoon is very important for them, and especially for agriculture, disaster management, etc. So they tried to develop this, make up some kind of strategy to prepare monsoon forecast, and that legacy is still going on. So early days we used to depend on monsoon forecast. Basically meant using statistical methods. Then recent years now we use a lot of highly complex climate models or mathematical models. Now we use. But then 2007, when I was again the director of National Climate Center, we developed a statistical prediction system. We call it Ensemble Statistical Prediction System, which is IMD is still using it as for operational work. And some years our forecasts are good, some years our forecasts are not good. So that happens. So monsoon seasonal forecast is very tricky. And almost 4 months in before we are saying that this is going to happen. So after all, we are trying to predict the natural process. And natural process. Isn't it? So then your second question regarding how. So if you assume that this about 50% of monsoon variability is there, everything cannot be attributed to this so-called El Nino, Indian Ocean, everything. Some variability comes from the so-called internal mechanism of the. Even though all SST, everywhere SSTs are same, but still monsoon can vary. Okay. We know we have Himalayas, everything, so that doesn't change every year. It's the same fixed places, but still monsoon can vary. And so that's called internal mechanism. So internal mechanisms also is very difficult to predict how the internal mechanisms are there. So we can predict only the part which is influenced by the oceans of Pacific, Indian Ocean, or Atlantic Ocean. That part we can predict. So that means everything of monsoon variability and year-to-year variability cannot be well predicted. That's one. So whatever we can predict is influenced by these oceans. And there also our success is not that good, but we have improved a lot substantially, and there is a scope for further improvement, which we will be doing it. On short range forecast, that means next 3 days, 4 days forecast. Any days our forecasts are pretty bad. So that's why people say when IMD says that monsoon, it will rain, it may not rain. You take an umbrella, it will not rain. So, but now that things have changed a lot. Early days we did not have computers, we did not have models to predict. So now we have best of best models, so-called state-of-art models. It's all mathematical models, high resolution models, and we use big computers to run the models. And our forecast for monsoon season, I'm talking, up to 4 to 5 days forecast was good. Monsoon rainfall up to 4 days, not more than that. 4 to 5 days, 7 days for 5 days, but not more than that. But that itself is very good. So next 3 days, 4 days, what will be the rain? How much is rain? A serious problem with the monsoon rainfall forecast is the prediction of the heavy rainfall. When it rains 20 centimeter, 30 centimeter, model don't really predict. Model may give an indication it is going to be very heavy, but the number, the quantity is much less than. So it is good. Models are good for predicting a low rainfall amount, moderate rainfall amount, maybe 5 centimeter, 2 centimeter, 1 centimeter. But if it becomes 10 centimeter, 20 centimeter, the prediction capability of the present models is pretty, no, I will say it's not good. But that is the prediction which really we want, isn't it? Because that is the rainfall for some 10 centimeter, 20 centimeter rainfall will lead to flooding even, flash flood or riverine flood, etc. So we need to really predict that heavy rainfall amounts. So at present the models are not that good. Some models perform well for some occasions, but in general I would like to say that models are not good. So there is a lot of scope for research for improving such. But if you ask me a question whether it is only for Indian monsoon, the answer is no. So it is a global phenomenon. Any model you take anywhere, the prediction of heavy rainfall, the extreme rainfall, is pretty hard.
That actually brings me to the next question is on, while not all of the variability is linked to climate change, some of it definitely is, especially when it comes to these extreme events and heavy rainfall events. And that adds a layer of complexity to what is already a very complex topic. What are these factors that are influencing? So is it rising temperatures in the poles?
So in all these are all natural variability I was talking. So you rightly pointed out the importance of climate change or global warming. And that is adding a new dimension to the so-called understanding our natural variability. We know how the monsoon varies in diurnal variation, seasonal, so intra-seasonal, seasonal. In all this variability, this global warming phenomena is contributing a kind of unknown mechanisms in which we don't understand very well. And also it will have a problem in predicting, for example. So climate change is really, there are a couple of things which we understood from our past data on the impact of climate change on the Indian monsoon. One is monsoon rainfall doesn't, if you really take all India monsoon rainfall, if you take 100 to 150 years of data, monsoon is a very robust system. It's very strong. Every year it comes, every year it goes. Every year it goes. So so total amount of rainfall, if you really see the trend, there's no trend. So monsoon still comes. But only thing, as I said, that some years it is less, some years it's more. So that year-to-year variability is very high. But there's no long-term trend. And also there's a multi-decadal variability. Some years, some epochs you tend to get more drought, so otherwise it's no trend. So monsoon is a very robust system. Especially I'm talking about Indian monsoon. But then the characteristics of monsoon, how it rains, so-called heavy rainfall event. The frequency of heavy rainfall events, especially over the northern parts of the country, is increasing. It's from observation, so there's no doubt about it. It is increasing. And also, as I told that in the monsoon season, every day it doesn't rain. It rains only few days. So when it rains, it we call wet spell or active spell. Then followed by a dry spell in which there's not much rain. And again a wet spell. That everywhere it happens. So now what is happening is the dry spell, the length of the dry spell is increasing. Okay, but the total amount of rainfall is same. So the number of rainy days is decreasing. So the the dry spell length is increasing. So, but the total amount is same. So what does it mean is that when it rains very, very heavily. Very heavily. Earlier we used to hit 15 centimeter, now it's getting 20-25 centimeter. Followed by a long dry spell. So it will have and if you really see the future climate projections from IPCC models, etc., these two things are going to happen in coming years. For example, still will the frequency of heavy rainfall amount will increase, the dry spell length will increase. So that will have a lot of impact on agriculture. The farmers should know that the total amount of rainfall may remain same, but the within the season how the rainfall is spread out, so-called characteristics of monsoon, rainfall within the season is going to change. So people should be aware. I'm afraid that most of the farmers don't know about this. So we need to teach them, tell them that this is going to happen in future. This is happening already and is going to continue in future. So they need to send out different strategy for agriculture operations every day. So that is an important lesson we get. So climate change is impacting Indian monsoon. So that's the story.
And are there steps already being taken or studies already being done that will equip us to better predict it in the context of climate change?
Yes, so as I said, the climate change is really troubling us in kind of prediction. So we need to improve our models to take care of that issues. In general, otherwise also even climate change was not there, we need to improve the models. As I said that models are not perfect, so we need to improve. So climate change is adding a new dimension to that. So we need more observations. We need better resolution model. At present, we use a global model of 12 kilometer. Which we personally feel may not be sufficient. So we need to go for 5-kilometer model. So already IMD and Indian Institute of Tropical Meteor, IATM, so-called IATM, already started doing that 5-kilometer model. They may make it operational maybe by next year or so. So 5-kilometer global model is a new thing which we are trying to develop. Then also data assimilation. So whatever data we get, you assimilate into the model. Then the basic research and also output, how we process it and all. And in all these process, so-called AI, artificial intelligence and machine learning methods also will be really helpful. So the methods we should already make use of it. Try to improve the monsoon forecast from the model output. So there's a lot of scope for further improvement, and models have to improve.
Are these AI and computational models, are they being currently
At
explored?
present, IMD is doing a lot of work on AML, but still there a lot of work a lot of work is remaining in the sense that we have not really started developing applications based on AML. So here and there we use some methods Because the scope of AML is very large, so it can be used to do the physics part of the models. It can be used in data assimilation. It can be used in post processing of the data, and also it can be used for developing applications. See, we may still keep telling that models have to improve, but my point is that models will. That's a ongoing process. It is never ending. If we are accuracy is 80%, we will say that we want 85%. So 85 means we will say 90%. So there is a never-ending process. So it is we can go up to 80 very quickly. From 80 to 85 it takes time. Okay, it's a very difficult job. So, but still people do it. We have to do it. I'm not saying we should not do it. But at the same time, whatever skill we have, develop application tools for the people. The people, for example, a farmer, a person who is doing in water resource management, cannot you cannot go and tell him, sir, no, I will wait. Let the model be improved and let us have 90% accuracy. Then I will give you the product. No, it's not so. Whatever accuracy. Only thing is, when we develop application, we need to tell them this is the forecast, but this also there could be uncertainty in the forecast. There could be so-called errors. So you tell them this is the forecast, but this is the uncertainty. So the person can, by understanding the uncertainty, they can use it for some specific societal problem. So, for example, water resource management, farmers, energy people, health, for example. So it's a lot of people who are making, and disaster management. So most important is disaster management. So application of weather forecast and climate forecast is plenty. So we are, frankly speaking, if you ask me a question, are we really doing enough work on application? My answer is no. Not enough work. We are doing it. I'm not saying that we are not doing it, but then there's a lot of scope for developing much more important application tools, specifically meant for the specific uses and user-friendly application. You can develop some application which the user may not know how to use it. There's no meaning of developing such tools, isn't it? So we need to, and more, it should be everything on digital base. Early days we used to send SMS, telegrams. So those days are gone. Now people are all in mobile. So you need a lot of development, a lot of mobile technology. You need a lot of digital technology to develop such tools. So a lot of work is remaining.
And in terms of the local context, local impacts, or emergency situations with regards to monsoon or unpredictable rains, is there a challenge with data accessibility, and is that something that is being worked on?
My knowledge, the data accessibility is not that bad. Anyways, I fully understand. So, for example, 2006, the story I told that how we developed the data sets. But now IMD provides the data to all people. So, and the data acquisition process also has reduced much. It has slowed down, it has improved a lot, the process, I mean to say. Any day they will send a request, then somebody will read the request and find out how much cost it will be, then send a letter back. Then he has to give money. Then once the money comes, then they will start retrieving the data. Now everything is online. So the data access is much easier now. Still, people may complain. That's a different issue. But then, compared to 20 years or 30 years back, the accessibility of the data is much better, especially real-time data. And climate data also, first of all, if you all want past data to work on research, it's also data are available, especially for researchers. In Indian universities, if somebody wants to do a research, data is completely, absolutely free. Anybody can. Only thing they need a letter from their boss or guide saying that this data are required. We give free of cost.
So, as the expert in the field, how do you wish your work and others' work in this field is translated into more actionable insights? Not just, and mainly for these stakeholders like farmers and agriculturists that you're talking about, but also for others, urban planners, disaster managers. What is your wish for that?
That's what I emphasized a lot, that simply doing research may not really be of useful. You can write papers, but then what's the use of that research paper? So I more emphasize more on its application somewhere. So the people should really read that paper, and it should be useful to somebody who can develop a, for example, application, improving their knowledge, information, etc. So as I said, that we need to go on developing a lot of applications, specifically targeting some user sectors. At present, our more focus is still on agriculture. I'm not saying that they are not required. That's very important. Farmers are required. But there's a lot of scope of now. See, the whole world is changing. And a lot of urban cities are expanding, so they have a lot of multiple problems. Disasters are increasing, so disaster managers want, for some landslides, for example, it's increasing, the frequency is increasing. It's all caused by rains, heavy rains. And energy for India is now investing a lot on renewable energy, solar and wind. So they need forecast for their operations, especially for solar and wind. They need operation forecast. For example, they want they'll be asked to provide what could be the energy available, solar energy available for next day, 48 hours. So that forecast has to be provided. So they will not. They are not good enough to develop that kind of tools. So IMD has a responsibility. IMD means Ministry of Resources has a responsibility of providing such tools for this energy sector. Health, for example. Uh, Rainfall variability or climate variability can influence the health. For example, chikungunya, vector-borne diseases, malaria, etc. are all governed by weather systems. If for more rain, for example, heavy rains, it can cause this kind of a cholera kind of things can happen. So people want to know work on health impacts on from the weather and climate variability. These are some of the example. Urban, for example, urban, and for example, people who are working in close to Himalayas, they need substantial forecast. But Himalaya, the climate change effect is very high, and so they want to know that whether their natural resources are getting affected. For example, the glacier, river water from the glaciers, rivers, etc., are really they're changing or not. Such kind of information. And fishermen, for example, fishermen who go out, they need a special kind of forecast. And the fishing technology changed a lot. Earlier, those small boats and all they used to have, but now the things have changed a lot. The large scale fishing is done, so they need a special kind of forecast. So I can tell so many other sectors where the weather forecasts are. So, but I personally feel there may not be any sector in which the weather forecasts don't have any impact on our day-to-day life. Somebody wants to have a marriage, they want to know whether it will rain or not, particular day, yes or no. And when I was secretary, I was remember that there were a lot of requests from big people asking, tomorrow is my daughter's marriage, whether it will rain. Another important example I'll tell you is, for example, I can tell now is, for example, we conduct Independence Day celebration, Republic Day celebration. Someday presidents conduct some kind of reception for visitors, big visitors, in the outside the Rashtrapati lawn. They want to know whether it will rain or not. So these are some good example. And even a small family, they want to conduct a. So they want to know whether it will rain or whether it will wash out the whole thing. So these are simple requests people make, but it's not genuine request. We should be able to address all these kind of issues. I'm not saying IMD is not doing it. I'm doing it. There's a lot of scope for much more involvement and improvement. They need to really target the user sectors and try to and talk to them. See, there's a very serious issue in this, which I used to always highlight, is that as a weather forecaster, I may develop a X kind of tools, and the user may have need a X kind of a Y kind of requirement. So these tools should be able to cope up, or should they meet the requirement of the user, isn't it? You, for example, you develop some protocols or weather forecast which the user doesn't want. There's no meaning. Similarly, weather forecast may need something which your forecast are not knowing or not developing it. So there should be a kind of interactive mechanism in which we understand the user sector's requirements and try to develop the tools which are not. So all the forecasts which the weather forecasts are preparing may not be required by the user. Similarly, users may have a big list of requirements which weather forecast may not be able to do everything. So then we need to find a subset in which we have skill of forecast, but at the same time users also need to such forecast.
Is there a specific problem statement that you think could be helped with private investment?
Yes, private industries can do a lot of help for improving weather forecast in this country, and that kind of collaboration is not happening in India like we have it in, for example, US. A lot of private industries are involved in weather the participating in weather forecasting operations and distributing weather forecast to user sectors, etc. So that kind of ecosystem is not available in this country. This is very unfortunate. and they can participate in many ways. For example, they can contribute in taking observations, putting a network and observation and sharing with the MD, and they can take these forecasts and give it to a particular sector, user sector. So the forecast developed by prepared by from the models are not really as useful as we think. It has to be post processed. It has to be put in a particular format and given to a particular user sector, for example, farmer. You cannot give the raw data model forecast to the people. So then you need a lot of interpretation how the forecasts are, how the accurate forecast, how the accuracy is, etc. Then you need to know the user sector what they need. So take these inputs and process post processing and give it to them. So that kind of process should be done. So there, private industries will play an important role. And in India, that kind of a large scale process is not really happening. We have a couple of them, private industries working in weather forecast and climate forecast, but this number should grow up. And IMD should work very closely with them. And my humble request to the private industry, they should not feel that IMD is a kind of a I will oppose what IMD is doing, and I will start developing the tools what IMD is developing. So they should all collaborate each other. So you should complement each other. That's a basic message which I want to give. The second aspect, which of course you did not ask, is how academic institutions can play important role in improving weather forecasts. In the US, for example, most of universities who are teaching meteorology or weather science, weather and climate science, they all do research. They do extensively research to improve the weather forecast or climate forecast in the US. So they have a very active participation. For example, National Weather Service in the US have a very active participation from the academic institution. So that kind of an active participation is not happening in India. Of course, in India, academic institution involved in weather and climate science is not very large. So even if so the close collaboration is not really happening. So academic institution, private industries, etc., private players, etc., can play an important role and help IMD to improve weather and climate focus in the country, which will be very valuable for the whole country. So that is not really happening. So there's a lot of scope for such kind of large collaboration.
In your current role, you're a vice chancellor of a university. So, what would be your message to aspiring climate scientists who want to get into monsoon modeling specifically?
See, in India, for example, number of people working in monsoon research is very small number when compared to, for example, China has their own monsoon. The people working on monsoon research in China is much larger. So we need more number of researchers, monsoon researchers in this country. And also because now I told that climate change is affecting monsoon. So the scope of monsoon research has increased substantially. And we have tools. I'm not saying that we don't have tools, but we don't have enough people, trained people who can come and do research and kind of really innovative research, not asking the old questions again, repeating the research, but asking a new questions, try to understand how it can be, what it will be like, etc. This kind of very genuine question, very innovative questions, curious questions they should ask and they should answer. So we need large number of monsoon researchers in this country, and as I said, they can also work on climate change impacts, for example, on monsoon. And ultimately, what we need is to improve our forecast, monsoon forecast. So that will help the society, and in terms of disaster management, or agriculture, or water resource management. So we need people working on basics climate change, understanding the impact of climate change and monsoon, then monsoon variability, monsoon observation, monsoon physical processes. We don't have enough people understanding the monsoon physical processes. I mean, how the monsoon cloud is, how the radiation interact with monsoon clouds, how the effect of aerosols on monsoon rain. So this kind of very important physical process questions on physical process we should be able to answer. So we need a lot of students to come. So I encourage, and we have in ATA University we have a small team, about two and a half people working on climate science, and we are also working on monsoon and understanding of monsoon. For example, monsoon onset processes, monsoon variability, etc., and whether we can predict energy resources in the coming years. Some seasonal forecasts when we make for monsoon rainfall we make. Similarly, can we predict can we make a seasonal forecast for solar energy available for next year? Wind energy available for next year? These are all some of the very genuine questions people ask. So traditionally I emphasize more on applications. than doing a fundamental research. So I may not claim that I have done a breakthrough research, but I will always say that I have done a very useful research.
Thank you, sir. If you like this podcast, subscribe to us on YouTube or wherever else you get your podcasts.